This is a short module, so we'll have time next week, I think, to just do a review of topics and your quizzes. Now you should have better comprehension after this of everything we did before. We're halfway done, and this should bring it together because we're going to talk about the calculator, the calculations, the interpretation. How many of you watched the conference video, the lecture? ¿Cuántos han visto la lectura, la conferencia? Okay, la conferencia is reviewing the notes, and you need to watch that one. Very good. Because there's not many other videos, right? That's the notes, and then I have some videos to do, repasar cómo se, how you get the equation of a line, how you do what is it? Remedial mathematics. Okay, good, good. Okay, good. So the quiz today will be on regression, and it'll be like last time, 2 questions. I'm only going to grade the best one, or whatever. I'll grade them both and pick the best one. So I actually wanted to start kind of like there's so many exercises at the end. I want to make sure you get through one that maybe I didn't get through. I'm going to show it to you. You tell me if you got to it. Exercise 4. And maybe I'll do it and then I'll take your questions after. Did you get to exercise 4? You can tell me in the chat. For last week, asistencia, I marked it very easy because I accidentally erased the chat. So it means that I couldn't see the exchange or the communication. So I just gave everybody, I assumed if you didn't have your camera on, you got 4 points out of 5. If you did have your camera on, you got 5 out of 5. Oh, and I forgot to give the Nacha, right? I forgot to give you, I have to add you a point. Well, who did it last week? Who did the timestamps last week? It was Nacha, I think. Is she here? Anyway, so I have to add her point. So if you, yeah, didn't have your camera on, I gave you 4 to 5 because I lost track. Anyway, I accidentally erased the chat. So what you need to do to get 5 out of 5 is have the camera on, and you need to participate, which is not just repeating what other people say. You need to communicate. You can ask me questions. You can answer questions. All right. I need to see that participation and that you're prepared for the class. So anyway, you guys got a bonus last week because if you showed up, you got 5 points. With the camera on. If you didn't, you got 4. But yeah, I have to make a backup before I start reviewing the chat because I erased it. Okay. Oh, 2 weeks ago. So who did it last week? Did anybody? Or did I not ask somebody to do it last week? I did it myself? I can't remember. I think I did it myself then. All right, so who wants to take the timestamps this week? For 1 extra point. And all you have to do is record the time of a topic. That's it. As you see, that timestamps are there. I make very few edits. People are doing a good job with the timestamps. Nobody? When you do the timestamps, you pay more attention. Okay, Nicole, gracias. So Nicole, you pay more attention because you have to pay attention to keep track. And if something's missing, I edit it, but it's very minor edits that I make. Okay, so I have posted this up here and asked, did you guys, well, I had a question that you guys answered, I think. Did you review the conference? Now I'm going to ask you, did you do this exercise? Did you get this far? Or did you get to this exercise here? Anyone who did get to the exercise, you can tell me. I'll assume everyone else that doesn't say yes did not, so I can get to this one. I'm going to get my iPad. Okay, so you didn't get here. Good. We can do this together. All right, and then I'll answer your questions. And yeah, well, whatever. If you didn't study last week and you want to understand, this is what it's for. Questions like this. Okay, so this is applied. This is finance, but there's several different disciplines or um, yeah, disciplines or fields in business, and one is finance. So this is a good exercise for finance. Oh, nobody did it. All right, so let's get out the calculator. Let's get out the calculator and let me get the notes. And the cable. Yes. Oh, and I can do it in Excel too. Did I do it? I did it in Excel in the video, didn't I? I believe I did, but let's do that too. Oh, I was really tired and now you guys woke me up. I feel alert. 30 people watching me wakes you up. Okay, here it is. Okay, so there's a lot of notes. Let's talk about this. So there's a lot of notes, but I told you that you really can stop at page 9. Okay, let me show you the notes. If you feel there's a gap, if you did just module 5, but you feel there's a gap, you have to go back. Remember, because I introduced this in module 3. I started talking about correlation in module 3, so you need to go back and see that explanation. Here we are. So there's the last page that you're responsible for, okay? The additional notes here are more theoretical, but I put them here for completeness to talk about. It's very important. And maybe if I have time, I can talk about it. Extending beyond two variable relationships, right? Because regression is really about relating many variables, not just two. The notes here are just for two. And I'm going to get to my exercise. So there's some theory about doing that, and this is talking about the assumptions if you do try and do it, and then how to make some corrections for the assumptions. So this just for completeness. I have this extra material. I usually give it to my statistics students. I always intend to offer another class. I actually have it in a couple of my class, well, 3 of my classes. I have this review for regression analysis with more than just one explanatory variable. Okay, so then there's the exercises. So you are not responsible for these pages, right? This one, sorry, go back to 9. It ends on 9, so 10, from 10 to, oops, 10 hasta 18, you're not responsible. Then we begin with exercises. So there's one exercise after another, which if you want to ask me, we can discuss it. Someone asked me to translate the tarea práctica, which I think you can translate with AI, but we can get to that too after. So it's in Spanish, so I think it was requested in English. All right, so here we are, page 25, it should be. And you're presented with 2 sets of data And I tell you, one is X and one is Y. But if I didn't tell you that one was X and one was Y, instead I said plot the relationship or the scatter plot or maybe I say graph the scatter plot. If I say one variable versus the other variable, I'm telling you this one is Y and this one is X. Okay, so this one is Y and this one is X. Okay, so if I don't write it down, that's how you know. I'm going to tell you to plot in a certain way. And there is a meaning here that you can interpret in finance because of an abundance of theory about the relationship between stock returns. So this is a company called Bell Canada Enterprise. Bell Canada Enterprise. It's a phone company. It's like Claro or AT&T. Okay, Bell Canada Enterprise. And the other one this is why I have my notes because it's hard to write efficiently. Okay. And the other one is the S&P 500. It is an index that's made up of the top 500 performing public companies on the stock market. Okay, so in terms of the value of stock, anyway, they're ranked and they're changed frequently and then put into an index. And this is a measure, people consider this a measure of the state of the economy. So it tells you how the economy is doing. Guys, read that state of economy, and that's a company. So I simplify that and I refer to this one as the market, the stock market, and this one as like a company's stock returns. Now, to make it even more confusing, sorry if this is more confusing, my variable are returns. These are percentages. Don't get confused. Just remember the units of the variables. Okay, so it means that if people invested in the index, which you can do, you can invest in the S&P 500. And there's other indices. You may have heard of the Dow Jones Industrial Average. There's other indices, the NASDAQ. There's other indices, right? There's other measures that follow or track if you were to invest like in a portfolio of many stock mimicking this S&P 500 and what you would get as a return. So you can actually invest in the stock market in the S&P 500, the top 500 performing stocks, and you get a return. So this means for each dollar you invested over this period, I'm not going to say years or months or weeks, but whatever, this period, you get 15 cents. You get your money back and 15 cents more. But if you invest it in the BCE stock, you invest for every dollar, you get how much more? After period one, how much do you get more? See if you guys are listening.
30.
30 cents, right? Okay, so staring at this data, what do you see? How do you interpret the result?
Is the double?
Who said it?
Carmen.
Ah, Carmen, thank you. It's double, it's double. Great. So the relationship is double, which seems good. It seems like a good thing, if it's double the market, that's good when the market's doing well. But what if the market is doing negative? What do you think will happen? Or do we know? So this is a practical application of relationship. Now we see a double. A double is a linear relationship because every time it's double, no matter what, but we have to be very specific. All of these values for X, the smallest one is 7.5 and the biggest one is 15. None of them were negative. So none of them were negative. Should I be able to imply what happens if S&P 500 is negative? What will happen to the BCE stock returns? What do you think? No, Javier gets it. No, you shouldn't because you only have data in this range, okay? If you try and imply or insinuate something about negative, that's called, you know the word for that? When you do something like that?
An extrapolation.
So we do not have the data to explain. No, no, who said it? Dorimar. That's right. It's outside of the observed data, which means it's extrapolation, extrapolation. So if you ever hear that word, do not extrapolate. Although people do it all the time, you have to be cautious about it, okay? So you could say, well, if that pattern continues, even when the stock market is in the negative, right? So if there's a loss in the stock market, you shouldn't. Okay? Even if you haven't, you say, oh, the tendency is going to continue when the stock market is negative. Well, you should be able to say something, but you should be careful. Do not extrapolate. Be careful. Okay, that's really important. It's not in it's talking about negatives is not in the range of data. You can go to 6, 6, and you can go to 16, and you can go a little bit outside, but you shouldn't go something dramatic back to the negatives. All right, so what we're going to do is we are going to characterize this relationship. We're going to find the mean of X and Y. We're going to find the standard deviation of X and Y. We're going to get the covariance of X and Y. We're going to get the correlation of X and Y. And we're going to get the slope. We're going to do it all on our calculator very easily. That's why I have you get this calculator. It's a game changer. And then we're going to put this in Excel, and hopefully it helps synthesize what you've learned. All right, so let's get the calculator. You see both. So my point about extrapolating, if you were to extrapolate, then although it's a positive or doubling when the S&P 500 is positive, The downside is that it could be doubles and negatives if the relationship continued when S&P 500 was negative. So that linear relationship we can only interpret in this range, but mathematically, BCE is considered a risky, sort of risky stock because even though it's great on the upside, a double is bad on the downside. Okay, when the S&P is poorly performing, that means BCE is going to be double. It's going to be double the, it's going to be worse by double. Let's say it like that. Okay, let's put this data in. We're going to do it with second data. There's something there. So I'm going to clear that. Second clear work. I'm going to do it once as slow as I can, and then I'll do it again. So do not despair if you get lost. So this is asking for the first pair of data. I'm going to put 15 in. I'm going to enter the data as a decimal, but I think you can do it just as fine with a percent. 0.15. I'm going to do it with a decimal because it's going to matter when I do the covariance calculation. So enter, scroll down, and now it's asking me for y. Okay, we have two variables, so now we're going to put the y in. Enter down. Okay, any questions so far? Next one's 0.09, enter down, and 0.18, enter down. The third one, 0.1, enter down, 0.2, enter down. The fourth one, 0.075, enter down, 0.15, enter down, 0.08, enter down. The last pair, 0.16, enter down. Okay, I really didn't do that as slow as possible, but I went kind of fast. Okay, again. Okay, again, from the top. I'm going to go from the top. I'm going to clear everything. I'll go slower. 0.15, enter, scroll down with the flecha, down. Then 0.3, enter, scroll down with the flecha. Now I'm on the second pair. So you got to work going across and down. 0.09, enter down. 0.18, enter down. That's the second pair. Now let's do the third pair. 0.1, enter down. 0.2, enter down. The fourth pair, 0.075, enter down. 0.15, enter down. And the fifth pair, 0.08, enter down. And 0.16, enter down. There you go. Oh, yes, Eska. Did you catch up? Sorry. Now what do I do? Does anybody know? We're gonna go to stat. Very good, Javier. But we hit second and then stat for the statistics. So this is familiar. This feels like we're getting the mean, but we're gonna get a lot more this time than just the mean and the standard deviation. So this is giving us the linear regression results. That's why it says lin, the linear regression results. And now we scroll down. There are 5 pairs of observations. The mean of X is 0.099. So we have that result. The standard deviation of X is 0.03. And the population standard deviation is 0.0269, a little bit smaller. Which one do I use? This one? Standard deviation of the sample or standard deviation of the population? Which one do I use? Very good, Yomar. So this is This is for the sample, right? Remember, from beginning to end of the course, you have to distinguish what's the sample and what's the population. This is just a sample of data. We can get a lot more data than this if we want it. All right, so then we're going to get into the y now. So this is the mean of y. This is the standard deviation of y of the sample, if it's a sample, and this would be if it was the population, but it's not. We always use the sample. Sometimes you may have to use the population, but we've been using the sample because I only give you samples usually. But if you're doing some exercises, there might be some, or if you guys are studying online, if you're studying with an AI or something, you might get confused because they'll assume that there's a population. So you need to know that. You need to know something before you use any AI because you won't know if they're teaching you wrong or what the assumptions are. So yeah, use a sample unless you're told it's population data or it's very clear that that's a census or all of the data available. All right, now we go here. A is 0. What is that? A is 0. Let's write it down. And next, B is 2. And then next, R is 1. So you guys studied some. There's some more statistics here. This is the sum. This is the sum of squares. This is the sum of y. This is the sum of square y. This is the product. Remember we talked about that. And then back to the beginning. All right, so questions.
I'm sorry, what was A? Like, what does that mean?
We're going to go to it now. Hold on. Let me make sure everybody got the same as me. Yeah, Claudia, we're going to
Okay.
talk about it. You mean, Ernick, you want me to talk about the standard deviation again? Just that we've used this one, the sample standard deviation, not this one, the sigma, which represents the population standard deviation. Okay, so we use this one. Okay, Yaseska, are you okay? Enter, enter y flecha abajo. So you're going down, down into the Excel spreadsheet or the worksheet, down, down with the flecha down. Okay, you ready? Tell me you're ready. Alondra's ready. Anybody else? Anybody else ready? What are A and B? Let's talk about A and B. Okay, so we have the data. Okay, so you told me, looking at the data, you told me it was double. Everybody could see a doble, right? It's double, double, double all the way. So that double is represented here. B is the slope of the linear relationship between the variables. 2, double. A is called the y-intercept. It's the point where x, what is x? No, when x is 0, what is y? That's going to be the y-intercept. In this case, it's also 0. It means it goes through the axis. Can you guys see that? It's very faint. I don't want to make it too dark. It goes crazy on me.
I'm sorry, what was B? The x-intercept?
Nope. You missed that? What is B, everybody?
I'm
Can you
sorry.
read it?
No.
B is the doubling. It's the slope. Right. That's how you see the double is the slope. All right, so what we're going to do, since it looks like some people didn't study yet, we're going to talk about, we're going to draw this. So we did the calculations in our calculator very easily. The formulas are all here, but we did all of this with the calculator. We got the mean of X and Y. We got the standard deviation of X and Y. We got the R and we got the slope. Look at that. So they're all here. We got them all except for the covariance. So let's talk about, before I continue, what I want to do is I want you to draw this relationship, make a scatter plot and look at it. Make a scatter plot of this relationship. You should always do that. Now you can draw it, or we can put it in Excel, which I think I'm going to end up doing to save time. So if you put this on an axis with X and Y, you always put the market here and you put the stock here. Oh, let me just put the symbols that I have. It's easier. This is BCE and this is S&P. And what you'll see if you plot it is it's going to go like, oh, why this has so much trouble. It's going to go like that. Okay, if you were to plot it. So what we're doing, I got to make this bigger. Okay, so if you plot it, it's going to look like this and this. Okay, so what we're doing with linear regression is we're trying to find out if a line, how close a line passes through those points. Now, this is an extreme case. In this case, they fall perfectly on the line. The direction of the relationship is the direction and strength of the relationship is captured in the statistic called the correlation coefficient. It's a measure of the direction and strength of a linear relationship between two quantitative variables. Okay, so it's a measure of direction and strength of two quantitative variables. So what is the direction of this relationship? First of all, are these variables quantitative? Yes. An example of non-quantitative variable is something like if you want to find the relationship between gender and income of people, you can't use the correlation coefficient, this one, because there's different kinds of correlations, but this one is not useful for this. Why? Because gender,
It's quality.
exactly, it's categorical. It's not quantitative. Categorical. Okay. Okay. So what is the direction of this relationship? Yes, Javier, you could not do it for gender and hair color. What is the direction of this relationship? It's positive. It's positive because the movement of X is mimicked by the movement of Y. When X goes up, Y goes up. So X high, Y high, X low, Y low. That is a positive relationship. Also, when X low, Y low. Okay, so that's the direction. The strength. How is the strength of this relationship? It's strong. Why is it strong? Before we even calculate R, why is it strong? What do I see in the picture? What do I see in the graph? Kind of want to go backwards with the graph. How do you see strong from a picture? All the points are on a line, right? And is the relationship linear? So what we have is a linear strong and positive relationship. Because we have these three things, we can calculate R. In other words, we could calculate R anyways, but R has meaning. And it turns out from our calculation, it gave us, in this case, R was equal to +1. That's the best you can get. R is an index. R is an index between -1 and 1. Okay, it's forced between -1 and 1. This is the graph. This is how the scatter plot. So this is the scatter plot. Just to be clear, the scatter plot is just the dots, right? I'm just showing you the line behind the scenes. Okay. So what does the line accomplish? What's the deal with the line? What's the line for? What do I care about the line? It's interesting. What's the line for? It's for exactly what we talked about on the first day of class. We want to alleviate uncertainty. We want to be able to guess educatedly, with an educated guess about what exists between the points that we've observed. What happens here? If we don't have data here, what can we expect? We're predicting, right? We're predicting. So we're using it to make prediction. Now, remembering what we said, we don't want to go too far out. We want to stay within the range of the data that it was observed. But we could say, if we want to estimate what happens here when the stock market is about here, and I want to know how much I should invest in BCE, that's a pretty good prediction to go with this one. Okay, in this case. So you go this way, you pick for an X, what would be the Y, in other words? Prediction. That's what the line is for. So we need the line to do that. So what is the equation of this line? And it's a statistics line. In mathematics, we have y equals a plus bx. That's mathematics. And that line will extend, depending if it was the line we're talking about, it will extend both ways through infinity. Positive, well, it's going to go up and down. But in statistics, that line only exists, like this line that I'm going to draw. I'm going to use my ruler again because I learned this works. It moved. I'm a little bit off of my center. I'll make my dots bigger. Okay. In statistics, I'm only drawing the green line around the observations. I'm not going too far outside. So what we do is we write it with a hat on it. Like that. Different from the one here that goes everywhere. We write it like this to signal that it's a prediction line and not every value falls on it, but we're going to use it to substitute around the range. Anyway, it gives a different meaning. All right, so this is the equation of the line. The equation of the line, oops, you should have learned this in high school, but maybe you forgot or there's some gaps. Basically, we have the information. B was 2 and A is 0. So for our example, for this one, y hat equals 2x. That is the equation of the prediction line for this problem. The hat implies that it can only be around this range of values. So somewhere around the negative 7.5 to positive 15. So, obviously, this is a tight, this is supposed to be 7.5 of my graph, and this is supposed to be 15. All right. Questions so far? Almost an hour in. So I taught you how to get everything out of your calculator. Let's calculate a prediction when what will BCE's returns be when the S&P 500 is, let's try 12%. So that's pretty common. That's like an average return. So what will you tell me? What's the answer to that?
$24.
Exactly. Did I really need the equation? No, because I see it's a clear relationship, but it's not always clear like that, right? It's just 2x. So we didn't need to get the equation for this. But I just wanted to show you where you can actually see it. It works out with your calculator, and it shows up very simply that it's just a doubling. So it's going to be the y hat when x is 12 percent, I can use 0.12, is equal to 2x is equal to 2 times 0.12 is equal to 0.24, which is 24%. Like I made this more complicated than necessary, but just to show you, with a simple case where you knew the answer, it all comes together. Let's do it. Let's do it in Excel. And then we'll do another problem with that's not exactly on the line, right? We're going to just do one with a scatter. So in general, what it looks like oh, what happened there? So what would the R be for this relationship here? Giovanna asked me, so we cannot use this equation to predict negative values. It's not advisable. You could do it. You could say, let's do it, but it's not as reliable as the results over here, Giovanna. Okay. It's not recommended. It would be an extrapolation. You have to be careful. Okay. People do it all the time. They take linear relationships and they extend them, and you shouldn't just think you can do that. So you have to make a disclaimer, warning that it's an extrapolation. Be cautious. So what would be the R of this one? Approximately. I didn't give you any data, just, yeah. Dodimar says about 0.8. I would say maybe a little less, but you could be right. So the point is that the R here maybe is 0.75 or something like that, or 0.8. Just gonna make it a little less. And then over here, it's even worse, right? So let's say 0.65, but is it a positive or negative? Yeah, it's going to be negative because as I don't see, the line isn't there, but I imagine a line. So what is the line? The line that fits closest to all the points is the best line, right? So with statistics, using calculus, you can find the line that fits closest to all the points. We don't have to do it manually. We have some mathematical results that help us to do it. So this one, the number R is telling you that the strength is the direction is positive, the strength is moderate, and it's linear. So this one would be linear. Sorry, I'm having trouble with this thickness. Okay, so this is a moderate, positive, linear relationship. And this one is moderate, negative linear relationship. You must draw the data first. You must stare at it first before you do any analysis, because in fact, if the data look like that, is that a linear relationship? So there is a relationship here. It's curved and non-linear. Okay, it's non-linear. So it means that there is a relationship, but it's non-linear. And you know what's going to happen if you didn't look at this graph? It actually turns out that the R of this graph is 0. So don't interpret statistics without seeing the data. Okay. Why is the R going to be 0? Because what we do when we calculate the R is we divide the data like that, and we see, actually, let me do that again, that last one. That's not exactly in half, though. I have to do that again. Yeah, it's better. Okay, so by doing that and dividing the data by the mean in the horizontal and the mean in the vertical, I have divided the axis and the variables into high and low. When x is high, so x is above this mean line, where is y? So when x is high, y is where? So when x is over here, when the x values are over above the median or mean, y is where? Y appears to be high. But also when x is low, when x is below, y is also high. So there's no real pattern that, for in this case, when x is high, y is high. Over here, when x is high, y is low, and it's consistent. These are inverse relate, like this is consistent all the way along, but here it's switching. And what's going to happen to the formula for correlation is that it's going to give a result of 0, okay? Okay. But that doesn't mean that there's a trend. So let's look at that formula. Yaseska, hi, I've divided the data in half. So I have the data on this side, the left is low, and the data on the right is high. So I change it into two things, high and low, not just a bunch of data. Okay, so let's look at the formula for a moment, because I want to talk about how we get this and this are out of the calculator, and so is this. Now, there's 3 different formulas I give you for correlation that I describe in the videos. But the best one the easiest one I want to talk about here is this one, because why? What does it say? Correlation is a standardized covariance, okay? Correlation is a standardized, so R so covariance, what is covariance? Let's look at the formula of covariance. Let's look at the formula for covariance. Here is covariance. What is this formula here? Sorry, here. What does it look like? Nope, it's not variance. It's covariance. So Javier, are you saying that the covariance looks like the variance? No, that's okay. It's my sorry, not understanding. So what is the variance? Okay, so this is the formula for variance. It's the average of the square deviations from the mean. Covariance is when you, see, because this is the variance, and then S is the square root of the variance, remember? You guys can't miss watching any of my videos. You need it all. So this looks like this one, but I'm looking at what happens when with the relationship when x is when x is high, so this is the idea of high. So I'm going to divide it by the mean. What will this calculation be when x is high? Would it be a positive or negative when x is high? What's high? High is above the mean. So when x is above the mean, what will this calculation be? So this will be a positive. And what will the calculation be here when y is high? When y is high. So when x is high, this will be positive. When y is high, this will be when x is above its mean, it's going to be positive. When y is above its mean, it's going to be positive. So when you have x high, y high, you will multiply those and it will contribute a positive. What about x low, y low? What happens? Let me erase this. So when x is low, what will this be? Positive or negative? And when y is low, what will this be? Positive or negative? Okay. And what is a negative times a negative? A positive. So that's why if you have this pattern in your data, when x is high and y is high, and the trend is reinforcing when x is low, y does the same thing. If the two variables do the same thing, it's going to contribute to making the covariance a positive. Okay, that's how you get a positive, because you're adding a bunch of positives up if you have that reinforcing trend. What if let me move that away. Let's do a negative relationship. What if a relationship is sloping down? So when it slopes down, it does the opposite, right? It goes when x is high, y is low. When x is low, y is high. So what does that look like? When x is high, what sign will this be? But when y is low, what sign will this be? So when X high and Y low, that will contribute a negative to the calculation. And when it's the reverse, because a positive times a negative, it doesn't even matter the numbers, it's just the pattern. So when X is low, this will be a negative because it's below the mean. And this one will, when Y is high, this will be a positive that's below, above the mean. This will be a negative. So adding, now we're going to add those together, and that will create a negative covariance. All right, so that's how it works. That's how that formula works. So if the trend is negative, you're going to add a bunch of negatives. If the trend is positive, you're going to add a bunch of positive. But sometimes it's positive and sometimes it's negative. They may cancel and give you 0. So I explained this in the videos, but I hope that helps. I don't know. So the strength, the direction is clear with the covariance. With the covariance, the direction is clear if it's positive or negative. The problem is we don't know the strength. The covariance calculation, the result varies depending on the variation of your variables, and it's hard to interpret. So instead, what we do is we standardize by the variation and reduce R to -1 and 1. And then we can understand the strength. So we don't work with this too much, except that it's the foundation for what you're doing. So you need to know that, understand what the utility of that is. I explain this relationship from here in the videos, but also you can see it here. So having said all of that, find the covariance for this problem from the results that you got out of the calculator. What is the covariance? Can we get the covariance from the calculator? No, we can't get it directly, but indirectly use this formula to get the covariance. Do you know how to do that? So I know that R is 1. What is Sx? Do I know Sx? Oops, what happened? There's Sx. So it's 0.0301. Or you know what I can do is I can store it. Let's just get rid of that. Let's store that in 1. And I'm going to store this in 2. Did I teach you guys about storing? Maybe I didn't.
Would you mind going through story one more time? Because I don't think I got it last time. I'm sorry.
So this is Sx, so I'm going to say store in 1, so it's there. So I can see it like this if I say recall 1. So we're going to use store number and recall number. Very good. So I'm going to get the values out of my results. And let's continue with the results. So that's in 1. And then I'm going to store this one in 2. Store 2. And then what I have to do to get the covariance is the algebra. The covariance of xy is simply R S X S Y. So I can just multiply them. R was 1, so that's easy. So all I have to do is take recall 1 times recall 2. And that's the correlation. A covariance, sorry, covariance. So in this exercise, if you want me to do it again, let me know. So in this exercise, I ask students to get the mean, standard deviation, covariance. I do all the calculations using like manually, and you can do it all manually, but I'm also showing you how to do it in your calculator very easily, knowing this relationship here. The calculator, Gerardo, or the explanation? Okay, I'll do the calculator again. So the only other thing we're going to do is talk about this, and then I'm going to go to Excel. We're going to go there in a minute. Okay, let's go back to Gerardo. All right, so back to the calculator. Okay, so my results are in stat, and I want to store the standard deviation. So I store that. I hit store in memory 1. So it's there. And then I'm going to continue
I'm
in
sorry.
stat. What happened?
Never mind. I just found it.
Okay, good. And I'm going to store y, the standard deviation of y, in memory 2. You could write them down if you want to write them down. I'm just trying to be more efficient. You can write them down as well. And then we want to multiply them. So we want to do this. To find this, we just multiply, cross multiply up. We unstandardize it, right? This would be unstandardizing it. So recall 1 times recall 2 is this. So the covariance it's raining a lot today, isn't it? Oh, it is here anyway. Someone. The covariance of xy is equal to 0.00181. And by doing it this, you might have the different answer because you rounded and wrote it down. But this is from doing the multiplication with all the decimals there. Okay, so it is a positive relationship, but it doesn't tell us 0.00181. I have no idea. Is that strong? So, or strength. Difficult to interpret. Right? It's just difficult to interpret the strength. I don't know what that is. I know the direction, it's a positive direction. So that's why we standardize it and we understand what -1 and 1 mean. And anyway, the range, we know how to interpret the range. Ernick, you got 1 for R, not for covariance. You got 1 for R. That's what I have here. There's no way you got 1 because these are not 1. Have a look at that again. Okay, let's see. The last thing. Okay, good. And Nick, make sure you're in Excel. All right, so the slope, this result to find the slope, manually, you need to know this as well. we saw it easily in the chart of the data. We could see it was double, the slope was 2, and then we confirmed with the calculator. So this result you get out of the calculator as well. But if you had to, if you were given this information, this is how you would calculate B. If you didn't have the data, right? If you don't have the data, if you're given this information, you can find B by going R times SY over SX. And I explain, you have to write this formula. You have to keep your papers. You have maybe a lot of papers or printing, or maybe you have everything on a tablet or on the computer. You need to write some of these down because you can't be searching for all these formulas, right? So this is a formula that you want to put on one sheet of paper aside that you have it nearby. Okay, so otherwise, I mean, you can try and remember the formula, and I tell my students to remember this formula by risk. You can say it as risk because the slope relationship, it was 2 for this data. When we use financial data, when we look at financial data the way we have here, using a market return with a stock, the interpretation of the slope that's higher than 1 means it could be risky on the downside. Even though, as I mentioned, we don't consider making estimates when the S&P is negative, we have to think, well, it's pretty bad, it's pretty sensitive or risky to invest in the stock because it's a high number, higher than 1. Okay. All right. Okay. So let's do some other data than this one. Okay. Let's do some other data in Excel. Do you guys want to take a break? You want to keep going? Last time we just kept going. You want 5 minutes? I'll get some other data set and we'll go in Excel. Any questions about this? Hope I didn't blow your mind or in a negative way. Hope it comes together that it's a very simple problem, but we can do all the same things. All these different versions of the formula. It's not a big deal because you can get it on your calculator. Okay? But the formulas are important to understand this sort of relationship where how does it calculate positive and negative? It's actually looking at the trend of values and how they are interrelated or correlated. No break? What do you guys want to do? Break, no break? Break. Okay, good. So let's take 10 minutes. Let's come back at 10:35. I'm going to pause the video. Remind me to turn it back on. Yoimar,
Yes.
tell me what's happening.
No, I just have a question
Ah,
regarding in assistance because I see that my punctuation is
oh, a question? Okay, I'll look at
a
it. I don't know.
question.
I'll check it. I'll check it. Which
Okay.
one? Every week or just that week?
Every week.
Oh, really?
Yes.
It shouldn't be. I never put a question there, so something's going on. I'm going to
Okay.
verify.
It's okay. I just wanted to ask you. Thank you.
Okay. Okay, I'm back. All right, did a lot of talking today. Any comments, questions? Do you prefer I teach the Excel now, or you can use for the quiz, you can use anything you have there, just you can't put it in AI. I will be able to tell because it's a short thing, and I mean, you're going to have to either use your calculator or use Excel. So which what do you want me to do now? We have an hour, like whatever, 40 minutes, 45 minutes. You want me to do the Excel with a different problem? Oh, sorry, I'm looking at the wrong chat. Sorry. Yes, Excel. Okay. So let me get some different data. So I did have several exercises in the notes um, with Excel. Let's go back to my iPad and then I'll jump. I'm going to open Excel now because it takes a while to open for some reason. Okay, let's see. So here, I have some data. You can check it all. Do you want to reproduce this together? We can do this one. This one is question 3. What's wrong with this data? It's weird. Infant. I think the table got bumped. 16. Oh, okay, so yeah, the data got messed up. Okay. Do you guys want to do this one together? Do you have another one you want me to do? So just because now we're getting to halfway, I'm going to post the Connect assignments this week. So you guys can work on that too. You're supposed to be starting probability. I'll start putting very simple single assignments so we can make up for the Connect that we're missing. I don't want to overburden you with extra things. It should be easy to give you extra points. Okay, so let's start entering this data that unfortunately, I have to fix this. You can see it goes 15 and then 16 and then age 3. That's the last data point is over here. And we want it, so which variables are we going to take? SBP versus age. The blood pressure and age. And which one is X and which one is Y? Tell me. There's just going to be Connect, Javier. You can do Connect for, it should be an easy 10%. I believe it's 10%. Let me double check what I'm saying. %10 for Connect. Okay, so we're going to take blood pressure here, systolic blood pressure, and age. So these two. And you're telling me SVP is Y, right? Because I said it first. So this is always the first one I say, it's Y against or Y versus X. So this one is Y and this one is X. And it's important that you draw them the correct way. You sketch them or assign them correctly, or you're going to have the wrong linear regression. Okay, I'm going to go to my Excel now. So let's put the data in. X and Y. I'm going to center everything. All right. So X is age. All right, tell me if I make a mistake. All right, 3, 4, 3, 2, 4, 5, 2, 3, 5, 4, 2, 3, 3, 4, 3. 16 observations. I'm going to put the IDs right beside just in case. So this is going to be the ID. 1, 2, 3, 4. So what you can do is number them and then just double click. It'll fill it in. 15. Oh, there's a 16th, right? And that's 3. We have 3 and 3. Okay, any questions? Did I make any mistakes? Let me check if I made any mistakes. Yes, thank you, Giovanna. All right. And then let's do the Y. So Y is going to be systolic blood pressure. So here we go. Put the num. Yes, this is just going to work. So 89, 90, 83, 77, 92, 98, 82. It's a lot of data. 85, 96, 95, 80. Javier, you can check the platform. I'm doing this right now. Check the platform, check Moodle. 79 at the top in the calendar. 86, 97, 92, and 88. 88, 92, 7, 86, 79, 80, 95, 96, 85, 88, 92, 77, 83. Okay, good. I'm just going to save it because you never know. I'll just save it for now. All right. So, okay. I didn't practice right before the class, so I might mess up. But okay, you're going to highlight the 2. We're going to make a scatter plot first. Thank you, Regina. Okay, you're reminding me. Okay, so highlight them, and then you want to make, I believe, a chart. So you say insert at the top. Oh, let's try it here. I think you can't see the upper menu. Insert chart. And I want the scatter. So I can go with the drawings here. You see that? And then I get my scatter plot. Oh, something's going on here. Oh, that's flashing. That's weird. So I'm just going to go up here in the menu. Insert, chart, scatter. And I get my data. And the data is very close together, which isn't bad. If it's close together, what will my R be? What will the R be for this? Oh, you can't see the screen? Share. Marilis, see at the top, sometimes it puts me in 2 pantallas. Click on the other one at the very top. Did you see it, Marilis? Marilis? Okay. Yeah, sometimes it pops off and you can't see anything and you have to go to the top of the pantalla and pick the one with the screen. Okay, so yeah, it's going to be close to 1. Good. So let's see. So that is my plot, X and Y. and it did it properly. So just double check. This is the axis. This is for the X. This is for Y. It's all close together. We expect 1. So now let's do, with highlighting the chart, the scatter plot, go over here to what it says, add element, add chart element. Oh, what is going on with my, this is not good. I have to hold it down. So you go down here. Okay, let me show you again. Add chart element, hold it down, and go down to trend line. So that's what we're doing. We're making a least squares prediction line, also a trend line. And look at the options that you have here. You can fit a line. You can fit a curve. You can fit a linear forecast or a moving average. Anyway, they're just variations. We learn about linear regression here and simple linear regression. But if you see a curve, you can try and fit it to an exponential function too. But we're going to focus in this class because of limited time on linear regression. So we're going to do this one. And there we go. We have the approximation line, but I have no statistics. So how do I get those statistics? Let's go back. Here, we have some options. If you double click on it and you see at the bottom, you can ask it to display the equation and display R squared. Now that is much faster than putting it in your calculator, but maybe not. I don't know. Maybe you're good at the calculator too. So there you go. There's the output. Let's look at what it says. Can you all see that? Should I make it bigger? Let me see. I make everything bigger. So let's interpret the results. All right. Okay, so it has things a little bit backwards. Like they put the B first, bx plus a. So what's the slope of this line? What's the slope of this line? And what does it mean? Now you have to go to the variables. Make me a sentence. What does the slope mean? We didn't get into that yet, so let's do it now. How do you interpret the slope? In words. You can do it in Spanish. What does it mean, the slope? So last time, the initial exercise I did, it was just showing the doubling, right? But how do you interpret it? How do we make a sentence? Not a generalization, but a sentence with 6.15 in it. Did you guys practice that part? So it all depends on X. If X is 1, how does Y change? If X is 1. Don't worry about 67, 679, this part. Don't worry about that right now. But if X is 1, how does Y change? Or if X goes from 1 to 2, how does Y change? That's a better way to say it. In numbers, I want numbers. Close, Nicole. If X increases by 1, so for each year, each additional year, what happens? Excellent. Dorimar has it right there, you guys. Cut and paste that if you don't know. It means if we move X up 1, so if it goes from 1 to 2 or 2 to 3 or what are the ages here, right? From 4 to 5, Y, which is the blood pressure, goes up 6.15. That's what it is. That's how you interpret the slope. So when X increases, so let's say it in words. For each additional year of life, I'll give you extra points if you make it a nice sentence. If for each additional year of life, SBP increases by 6.15 units, whatever that is. I'll just say units because I don't know if we said the kind of units they are. Okay. Okay. So for each year, so this is all about because the slope is the change in y over the change in x. And we interpret it one by one. Like when we look at that, we imagine a 1 underneath 6.15 divided by 1. Oh, that didn't work out. Let me edit that. Can I edit this? Yes, I can. Change in y. Slope is the change in y divided by the change in x. Okay. And we can say also this is based on a sample of data with the range between 2 and 5. So, you know, the line mathematically can go all the way here, but that doesn't even make sense to have a negative age of a baby, right? So that's weird. And this relationship might not be the same as somebody ages. Okay, might just exist for babies or these are like toddlers, young children, not infants, to child. All right. All right, so what is this now? 67,679. What does that mean? How do we interpret the y-intercept? Okay, so I taught you, explained about extrapolation, that we shouldn't be making estimates away from the data. And as you see, the data is very tight. But if we were to extend this line over here, what would it hit? What number would it hit over here if we extend this line over here?
70 or 60.
That number, right? 67.679. That's where it will hit. Very good. It will go right here, right below 70. 67,679. Very good. Or it's this number here. So that's what you're giving me. So you guys are right. When age is 0, so it's just about to be born, this predicts that SBP is 67.679. Oops. 67.679 units. Okay. Now, whether that's actually true depends on whether this relationship continues over here. I don't have enough data to say that, but mathematically, that is where it's going to hit. That's what that number is for. Okay. So the slope tells you for every unit of age, and this just tells you, this helps you get the line, right? So the fact is it's not going through the 0, 0. So it's up here is basically what it's saying. It's happening above the axis. So that's what that is adjusting for. All right. Any questions so far? So we can make a prediction. So predict what SBP will be when, give me a value of the data that's not there. We have 2s and 3s and 4s. What if a child is 4.5 years old? So what will SVP be when a child is 4.5 years old? We'll talk about R squared in a second, Ernick. Very good. We'll get to that. Let's just do this prediction first. Okay, so Carmen, how did you do that? You went to calculate it, you use the equation. You say y hat, it actually should say y hat on Excel, but it doesn't. So y hat is equal to 6.1535 plus 6 times. I'm going to just put beside it times 4.5 plus 7.679, and it equals, oh, well, I don't know if it equals that. Did it add it properly? That's creepy. I did not write that. So apparently the chat and Zoom can do math. Didn't know that till now. There's AI everywhere. It's creepy, creepy. I did not add that. You guys can try it in the chat. So 95.37, and you can say 95.37 units. All right. Whatever the units are. In this case, it says MMHGs. MMHGs. Any questions so far?
Professor, can you explain again the uh somewhere like in the gray area that the formula appeared? I didn't quite catch that.
This calculation here in the chat?
The formula
This
above the line, yeah,
formula?
that form, yeah.
That's the line. That's this line. That's what the formula is. It's a line. So if you need to review lines, you got to go back and watch the video on lines. But this is the line. This is yeah, you're gonna have to go back and watch it. But this is the line, A plus BX.
And that
This is
you
the
you
A.
hit somewhere in Excel that you put in the bottom like
Oh, how
add
did I get
formula
it?
or
Oh,
show
how did I
formula.
get it? How did I get it? Okay, okay.
Yeah,
You know what?
yeah,
Let's
the
let's let's
button in
finish the
Excel.
question and then I'll draw it again, okay? Because I was feeling like it went too fast. I'll go back, Alondra. Was it Alondra or Carmen? Okay. Yeah, I'll go back. Sorry.
Yeah,
Okay. So
thank you. Sorry.
no. I was feeling it too that I went too fast. And so that's how you make the prediction. What is R square? Is somebody going to tell me what R square is? R square is literally the correlation square. Okay, so correlation. So what is correlation in this case? If that R square is correlation square, what is correlation? The correlation, if R square is just the correlation square, then you can find the correlation by taking the square root. What is the square root of this number? What is the square root of this number? It's even a higher number. Nacha got it, 87.87. Okay. So maybe you don't understand everything I'm doing, but you're getting parts of it. Let's count on the parts of it for now. Okay, so the square root of r squared. So the square root of 0. Well, let's see if the chat can do it. 7584, which I'm very scared by. Oh, look, it did it. The chat. The chat did it for me. Oh my gosh. So there it is. And okay, so what's the difference between r and r squared? Mathematically, r is correlation, and r squared is called, I'm putting it in the chat. R squared is called the I'm going to go to the notes to review this before I continue, because I have it all written here, what you need to know on page 9. I'm going to share that with you. So r squared is the coefficient of determination. And I'm going to go back and then I'm going to draw this for you. On page 9, I have listed all the things you need to know from this module. So basically, I have a review, or I have a list of the things you need to know in simple regression. These are all the questions you need to be able to answer for this material. You need to know how to make a scatter plot and interpret it, whether it's linear or not, whether it's positive or negative, whether it's weak or strong in relationship. You need to be able to find the r. You need to be able to interpret the slope and the y-intercept. We did all these things just now. You need to be able to make a prediction. We just did that. We need to find the residual value. I guess we could do that too. So that's how far you are off of the line. And you need to determine if a value is influential observation. We're here, number 9, the last question. What proportion of variation in y is explained by x? In other words, find r squared. This is what r squared gives you, the proportion of variation in y that is explained by x. So if you square r, it becomes a percentage, in other words. If you square r, it becomes a percentage, and you interpret it with this interpretation. So let's go back to Excel. So this is page 9 of the notes. So I'm just going to write it over here on the side maybe. So r squared equals 0.7584 means 75% of the variation in y is explained by x. Okay, that's so let's put in the sentence. So you can write that sentence in your notes on your formula sheet that you're preparing, for upcoming tests for the final exam. R is the percentage of variation in y explained by x. So in the terminology of the problem, 75% of the variation in, what was the y again? Systolic blood pressure is explained by age, which is pretty high. 75% of the variation is explained by age. That means 25% is not accounted for. There's another variable that could be responsible for that, or creating, influencing systolic blood pressure. Obviously, there's other variables. but age alone estimates 75% of it. Maybe genetics can explain the other part. Diet can explain the other part, right? That's missing. Other things, other factors. So simple regression, you don't want to overstate, the results, but this is a start to helping you understand how to use regression. But in terms of the variation, there's a relationship that 75% of the variation in the Y is explained by the X, and the rest could be explained by diet of the child and genes and things like that. Genes like, if it has certain conditions, diseases. All right. I should write health status. Health status, diet, and genes, etc. Okay, and R, we found R. What does R stand for? R, we found, was equal to 87. It's not a percentage, it's an index. And what does it mean? We saw the scatter plot that everything is on the line and it's positive. It's a strong, this R means that of 87.87 means that there is a strong positive linear relationship between age and SBP. For infants. Got it? All right, let's do the only question I didn't do is the residual question on the influential observation. So this is, I do discuss everything here I discussed in the notes. Let me talk about how you plot it first, and then I can talk about that before we go. So how did we do this? Nicole, who was it who asked me? Sorry, my memory. It was is it Nicole? Alondra, thank you. So how did I do this? Let's start over. Let's go here. Let's erase it. I'm going to erase. So what do you like better, the calculator or Excel? Excel is easy if you remember how to do it. If you forget how to do it, it's very frustrating. Okay, so highlight here. Yeah, don't forget how to do it though. Make notes or clip this video. So highlight. I'm going to insert from the top because it doesn't work for me, whatever reason. Insert chart and pick scatter plot. And you get this. Can you do that, Alondra? And then, yeah, you were asking for this. So now it's highlighted. You see, it's like active. Now I can go to, if I right click, does it work? No, that's for formatting. Okay. So then you go up here in the upper left corner, it says add chart elements. Do you have that?
Yeah.
Oh, good. Okay. Now hold it down and go to trend line to the bottom. So remember, you can only do Excel, you guys, if you have the data. If you don't have the data, you have to use the calculator. I mean, you have to use the calculator. You have to remember those formulas. Okay? So just keep that in mind. If you get the data, you can use Excel. If you don't have the data, you have to go back to the formulas I just flashed earlier we were working on. All right, so I'll review that in a second. Linear, that gives you the line. And then you can double click on the line, touch the line and double click. And then another box comes and you pick the two bottom boxes, you check them, and it gives you those results. Let me know if you got it.
Yeah, I did. I missed the clicking the line
Click on
to
the
get
line,
the,
write
yeah.
it down. You're going to forget. I mean, I forget every time I get nervous because I don't want to forget any of these things. But it's hard to remember. A lot of things happen. And yeah. So today,
Prof,
mhm,
I'm so sorry. It's just Jessica. You need to make double click in the line.
double click on the line and then
Okay.
you get a box. You see the box? You click here in these two boxes here. It turns it on. Are you seeing that? Yeah, you can see the box, right? You click here and it turns it on and off. Got it?
And then you see the result.
And you see the result on the chart. And you can make it bigger if it's small, I think. Anyway, I'm going to make it bigger with this to see bigger there. All right. You guys can use okay, so for the quiz, upload, if you use Excel, upload your Excel file, save it and upload it, okay? If you use handwriting, you upload that. I didn't mention that. I'll have to add that to the instructions, but yeah, just send me the Excel like this. Don't send a PDF Excel. Don't send a PDF Excel. Send it like this. Send it like this. Just send the file. Let's see. Okay, let me talk just briefly about the formulas again. Let's go back. Any questions about this first? You like Excel, don't forget how to use it. Make some good notes for yourself. In terms of uploading your results, make sure you upload it before the timeout because it's going to automatically send your results. Okay, if you need more time, let me know. When you're uploading, some people are having trouble. There's you have to click 3 times to make sure it goes. First, you have to say you're done, then you have to say it's okay, and then, I don't know, it's 2 or 3 times you have to click. Make sure you've uploaded it before you leave. Make sure it's really gone. And if not, just as a backup, save all your files. Okay, save your files, save your papers in case I don't have them in my record. All right, so let's see. I just want to show you one last time these formulas that we talked about. Where was I? Over here. So this messy thing here, just remember the ones I circled, right? This one and this one. Make sure you write them somewhere. Easily accessible. But all these other formulas, you can get this out of your calculator, this out of your calculator. All of these are from your calculator, but if you want to get covariance, you need to do this. If you need it. If I don't ask for it, you don't need it. If you don't have the data, but you have R, SY, SX, this is how you calculate the slope. Okay, so write that down somewhere. You might need that. Okay. And then this week, today, while it's fresh in your mind, if you're not exhausted, finish your review of correlation because it sounds like some of you haven't finished. And I hope my review was enough for the quiz, but make sure you have a good understanding by reviewing the documents here. And there's several exercises here to work through, and you can ask me if you have any questions. There's also the tarea. If you're having trouble because you want it in English, you can let me know. I can make the English document, but I think you can do it too. You can, there's AI everywhere right now. Like I said, the chat of Zoom is doing my math calculations. So, if you don't know how to do the AI, remember I showed you, you just make a screenshot and cut and paste, and it should translate everything for you. All right, so unless you have questions for me or comments, I'm going to get out and we'll meet you back in here for the quiz. You can communicate with me in the quiz in private. During the class, you should communicate in the big chat, because if you communicate only in private with me in the chat, like if you have private things to say, communicate in private. But for participation, you have to be in the group. So I'm wondering if some of you who have no participation points, it's because you're talking to me only private. Okay, so for the participation points, you have to talk to the group, because it doesn't save all the chats. It just saves the group chat. And I can go through the video anyway. I could, if you want to defend that you have deserved points, maybe in the video you've spoken up or have commented. So I should probably read everybody's name who comments on the chat, but that might be lengthy. All right, so let's get out of here unless you have comments or questions. And get the idea, get into the habit of putting the formulas on a sheet of paper that you're going to work with on these quizzes. We're halfway through, so now you guys know how it works. And let's take advantage of the experience. Okay.